Okay, so this lesson is just in your note package. It's not in the workbook, though it's a big part on the exam. So I'm not sure why the workbook is missing this section. But take out your note package and I want you to open up to this class example here. So it's class example 7. What we have already done is I've given you equations and you have to graph the equations, right? Find the VAs, find the HA, find the holes. The second part of it is the opposite. I give you a graph and you find the equation. So I will show you how we do this. We're going to mark a few things. This here we know would be our vertical asymptote, right? So below this, let's write the equation of that vertical asymptote. So the equation would be x is equal to -2, right? From there, we know that VAs are from factors, right? The factor in the denominator that didn't cancel. So what's a factor that would give you x is equal to -2? That factor is x plus 2. So if we have y is equal to and set it up as a rational, I know that one of my factors in the denominator is x plus 2. Okay, so that's one thing I know. And this is going to come from, that's going to be my VA, right? The VA of that is going to be x is equal to -2. It is not going to be common, right? There's no x plus 2 up here, or else that would be a hole. Okay, it says there is a hole in the graph at, so let's write the point of the hole. It's at x is 0 and y is 3. Let's write x is equal to 0. Remember that a hole comes from a common factor. So for example, if you had a hole, I'll just quickly show you because it's harder to see with x is 0, but if you had a hole right here, then you would know that there would be a common factor at x minus 2, right? X minus 2 up top, x minus 2 on the bottom. But because our hole is at 0, what's the common factor? It would be x. So there's an x in the numerator and there's an x in the denominator, right? Because if I just gave you this and I said, okay, what does this represent? You say, okay, this is not common. That's a VA at x is equal to -2. Here's a common factor. That would be our hole, right? So common factor is the hole. And the equation of the hole is x is equal to 0. There's going to be a hole at x is equal to 0. Okay, vertical asymptote we already have. We had that was x is equal to -2. The horizontal asymptote, there's one at y is equal to 1. There's an x-intercept at, right, here's your x-intercept. So x is equal to -6. And this will be new. But what happens is if you have an x-intercept, you say to yourself, what's the factor that would give you that x-intercept? It would be x plus 6. And this is actually going to be the remaining factor in your numerator. So whatever your x-intercept is, figure out what the factor is, and that's going to be the remaining factor in your numerator. So that in my numerator would be x plus 6. And this is your equation. So you're going to be given a graph. Okay, this will be long answer. There's going to be 2 of them. You're going to be given a graph and you have to come up with the equation. We're going to do a few of these. How you would verify if this was an exam question, let's in our calculator punch in our numerator and our denominator in y is equal to, and let's look at the graph. So open bracket x, open another bracket x plus 6. Close 2 brackets, divided by, the common factor was x in a bracket, and then x plus 2. Okay, so if I graph this here, you'd be checking a few things. In our graph, there was a hole at when x is 0, y is 3, right? So if I look at my table of values, when x is 0, there's a hole there. That's the hole. And then we knew that there was a VA at x is equal to -2. So I go up to my graph. At -2, there's a VA. So that's where the error comes from. My my horizontal asymptote is going through y is equal to 1, so that's there. And then let's check that that x-intercept is the same. So second function, trace a value. When x is -6, let's make sure y is 0. And it is. So if this matches your picture, then your equation for your function is correct. So you might want to star this one, and I want you to star this one. Okay, the graph of the function below can be expressed in this form, where f of 2 is equal to -1. If you are given this, that's an x value, that's a y value. They've given you a point. When x is 2, y is -1. So that's a point on the graph. And they've actually put the point here when x is 2, y is -1, though sometimes you'll get a graph and they won't give that to you. Like they won't show the point there and they'll just write it like this. And you have to just be able to say, okay, that's a point. So how do we figure out what the equation of this function is? Put your VAs in first. All your vertical asymptotes, get those in. So there's a VA here, x is equal to 5. What's the factor that gives you a VA of x is 5? X minus 5. Yeah. There's a VA here at x is equal to -4. What's the factor that gives you -4? X plus 4. So I know in my equation y is equal to, I know that if those are VAs, they are in my denominator and they're not going to be common, right? Because common would be whole. So I'm going to put x plus 4 and x minus 5. Okay, and then it says the numerator is going to be ax. So let's just write that down. There's no holes, right? No holes here. So I don't have to worry about a common factor. And if I look at this equation that I'm given, it's an expanded form. So let's get out of factored form and let's go into expanded form. So you should have x squared. What would that be? Minus 5x plus 4x. So that's minus 1x. And then minus 20. If you look, we now know what our value of b and c is because it says it's going to give you x squared minus and then your b value. So here's your b value. Your b value is equal to 1. And then it says it's going to be minus your c value. So here's minus and then there's your c value. C is equal to 20. Remember that I said if you have a remaining factor in your numerator, that's your x-intercept. So this x, that's a remaining factor in my numerator. So that's the remaining factor in numerator. So that is my x-intercept. X-intercept at 0. And that would be the x-intercept, right? Remember, if the x-intercept on this graph was at 3, then your remaining factor would be x minus 3. The remaining factors are going to always give you your x-intercept. Okay, now we need to figure out the last value, which is the a value. In order to figure out a missing value, you need a point, and that's why they gave you this. So we're going to use this point here, and we're going to plug it into here, right? So y is -1. And they want x to be 2. So take that out and put in a 2, so that becomes 2a. And then put in a 2 every time you see an x here. So that's going to be 2 squared minus 1 times 2 is 2, minus 20. -1 is equal to 2a over, So that would be 4 minus 2 is 2, minus 20 is negative 18. We need to solve for a, so get rid of that negative 18. Multiply both sides by negative 18. 18 is equal to 2a. And then isolate your a. And a is equal to 9. And then you would have this here. So you get a question on your exam, 2 of these, where you're given graphs and you have to go backwards and get the equations. One will look like this, and one's going to look like this. So you just have to make sure that you practice these. Okay, let's skip to this one. So this is the handout that I gave you. Thanks, Kevin. This is the handout that I gave you today. So let's go through this. It says, and this is something, again, you have to be able to do this. That's why we're going through this. Match the equation of each rational function with the most appropriate graph. Give reasons for your choice. You are given 3 different equations of rational functions, and you are given 3 different graphs, and you have to match and then give reasons. So let's start with this guy. Okay, so if I gave you that function, so a of x is equal to, remember we always factor. So you got to factor that numerator and factor this denominator. So what I could factor from the numerator is a GCF of x. So take out an x, and we're going to have x plus 2. Then, in the denominator, if you factored x squared minus 4, that's a difference of squares. What does that give you? X minus 2 and x plus 2. If this was your equation, what would you do? You would take out your highlighter and you would highlight this x plus 2. That's your hole, right? There is a hole in this graph. If that's a common factor, there's going to be a hole at x is equal to negative 2. I know which one it's going to be, right? It's going to be this graph here. But let's do a few other things. Like, let's just make sure with other things. This x minus 2 factor is going to be a VA in your graph. There's going to be a VA at, because you need to do this for like the explain your reasoning, right? So there's a VA at x is equal to 2. And here's my VA. The equation of that is x is equal to 2. Here's my hole. Okay. Remember that if there's a remaining factor in the numerator, so that would be this x, that's your x-intercept. So this is my remaining factor. Which means there's an x-intercept at 0, which would be right here. Okay, and let's check one more thing. Let's check the horizontal asymptote. So if I go to the original, the degree of the numerator is 2. The degree of the denominator is 2. Remember your justification for horizontal asymptote, you have to say, okay, degree of n of x is equal to degree of d of x. Therefore, there's an HA at y is equal to a over b. A is the leading coefficient of the numerator, b is the leading coefficient of the denominator, which would be 1 over 1. So there's an HA at y is equal to 1. And I'm going to go to that graph, and right here, that's my HA at y is equal to 1. So A of x matches up with graph 2. And there was a homework question from Friday's homework. Remember I said I don't think I gave it to you on Friday and I just uploaded it on the classroom and I starred it. You need to be able to understand that. And it's very similar to this, except it gives you 6 graphs, so it's even better. Let's do b of x next. Okay, b of x, I'll just do it over here. Factor numerator, factor denominator. So you say to yourself, numerator is going to be GCF. So I could take out a 2x plus 2. Denominator is going to be, you say, can I difference of squares that? And you cannot because we have a positive here. So that cannot be factored. X squared plus 1. Remember, we always say to ourselves, to get the non-permissible values, we take that denominator and we say it can't be equal to 0. X squared can't be equal to -1, but we cannot square root both sides because we cannot square root of a negative. What that means is there's no VAs and no wholes, right? If you can't get an NPV from the denominator, that means no VAs, no wholes. So it's going to be one of these graphs that doesn't have a VA, doesn't have a hole. So these have VAs, it's not going to be graph 1, it is going to be graph 3. But let's figure out a couple other things. If you have, remember, a remaining factor in the numerator, so look at your numerator, this would be a remaining factor, right? That gives you your x-intercept. So this is my remaining factor. X plus 2 is equal to 0. X-intercept is equal to -2, which is right here. And then let's figure out the horizontal asymptote. This guy, degree 1. This guy, degree 2. So write about what the HA for this would be. So degree of numerator is less than degree of denominator. Therefore, there's an HA at y is equal to 0. Now, this throws some students. Remember I talked about this in the last class. Sometimes students would look at this and they'd say, well, that can't be an HA because the graph is cutting, like it's going through the HA. It doesn't matter for HAs. What matters is the end behavior. So this graph is going to keep going on and it's going to approach 0. And then the end behavior of this, it's going to continue forever to -x, but it's going to get closer and closer to 0. So that is still an HA. So we said that this was graph, b of x is graph 3. Okay. Let's do the last, oh, did I make a mistake somewhere? I all of a sudden started talking about c of x. Sorry, you guys. For the degree, I don't know why I was talking about the degree for c of x. It's the same actually for here. So this is a degree 1. So degree 1. This guy was a degree 2. And then that's where I have this. Degree of numerator is less than degree of denominator, horizontal asymptote. Okay, let's do c of x. So the last one is c of x. And c of x, if you factor, you have 2x all over a difference of squares, x minus 2, x plus 2. You look at your denominator and you say, are these common factors? They're not. So then what would it be if it's not a common factor? It's got to be a VA. So there's a VA at x is equal to 2, VA at x is equal to -2. Right? Here's the -2, here's the 2. This is the remaining factor in the numerator. which is going to give us an x-intercept. If you set that factor equal to 0 and solve, it's going to be x-intercept of 0, which is right here. And then what do I have last for c of x? Let's look at the HA. So the HA, numerator is less than denominator. Degree of numerator is less than degree of denominator. So degree of numerator is less than degree of denominator. Therefore, there's an HA at y is equal to 0. So if you look, and a lot of students would, if they said, see this graph and I say, what's the HA? They'd say there is no HA, right? Because this middle part is going through it. Does not matter. You are looking at the end behavior for horizontal asymptotes. That would continue to 0, and this would get as close and close to 0 as it can without touching, okay? So that's how you would do a question like that. Let's do a couple more from the note package. This one we're going to do, and you'll understand it. I don't want you to star this one. The two that you are going to be studying for the test is going to be this guy and this guy, okay? The reason why it won't be this one is because it gives you an equation that's different. You're always going to be doing equations in factored form. So we'll just see how we could justify and get through this one. Okay, what's happening here is my VA, what's the VA equal to? X is equal to, what would that be? X is equal to 2, right? So the factor that gave you that is x minus 2. So right here, that would be the factor. Because the h, right, so what's happening is my asymptote, which was at 0, it moved 2 to the right. So h is equal to 2, right? It moved 2 to the right. So that would be x is replaced with x minus 2. So we have so far y is equal to a over x minus 2 plus k. K is going to be your vertical translation. So how much did the original asymptote move up? And remember, you guys, the original asymptote in y is equal to 1 over x, what that graph looked like was this. So there was an asymptote at y is equal to 0. That was an asymptote, right? That moved up 4. The asymptote was vertically translated 4 units up. So k is equal to 4. And then to get the a value, you need a point. You pick any point on your graph. So let's say we were to pick anyone that they gave you. Let's pick this one, where x is 4 and y is 8. So into the equation that we have, put your y being 8 and your x is 4. So 4 minus 2 would give me 2. Let's isolate this rational by subtracting 4 from both sides. And then isolate a by multiplying both sides by 2. And we get a is equal to 8. So the equation was 8 over x minus 2 plus our k value was 4. And again, you could graph it into your calculator and you could just check points, right? You could type in calculate a value when x is 6 and then y would be 6, right? Or calculate a value when x is negative 2, y would be 2. These points would match up. I want you to try this diploma question. So find this one. Based on the example we just did, see if you could do this now. So it's very similar. It's written in the same way of what we just did. You've got a k value that you have to recognize, and you have an h value that you have to be able to get out. And it's from there, it wants the equations of the VA and the equation of the HA. So that's my factor. There's a vertical asymptote at x is equal to -1. So that would be this one. And you'd have a 2 there. This is my k value of 3. So the HA, which is normally at y is equal to 0, moved up 3. So that would give us a new HA at y is equal to 3. And that would be 8. Okay, so that's how you do that guy. And then let's do this one. Okay, so this is more a review of just what we would have done on the quiz, right? This is what we did last week. So let's get this equation. Let's get all the NPVs, see if there's any holes, be able to write the domain and range, and be able to get the x and y intercepts. So again, if you have this, factor it. So look for the two values that multiply to -12 and add to -1. So that's going to be 4 and 3. Do you see this, Gabriel? It'll be in your note package. Show where it is. So just keep flipping. It's in your note package. Yeah, we just would have passed it. Okay, so you always factor. Highlight if something's common. If it's common, then you need to state what that would be. Connor, what does this mean if these two factors are common? Is that a whole or a VA? That's going to be a whole. So this graph is going to have a whole at x is equal to -3. So we got to find the y value of the whole. And then it's going to have a VA at x is equal to 4. Okay, so go through all of that. Is there going to be an HA? So let's do the HA. Degree of numerator. Degree 1, degree 2. So n of x is less than the degree of d of x. Valentina, do you remember where that would be? horizontal asymptote. Yeah, y is equal to 0. Okay, after that, I need to find, so this is where some of you had trouble on the test. You got the y value on the whole wrong. So what you do, after you get all of the VAs, all of the HAs, and your whole, now we need the y coordinate of the whole. So what you would do is you would simplify your rational function, and you would have y is equal to 1 over x minus 4. To get the y value of the whole, you need to input a negative 3 where you see x. So that would be y is equal to 1 over negative 3 minus 4. The whole, or the y value of the whole, is going to be 1 over negative 7. Okay, so that's where the whole would be. I think on your test it was like negative 1 over 6 is what the answer was. And that's how you'd get it. You simplify your rational function, put in your whole, your x value, just put it into the new simplified equation. Okay. Now from there, we could do domain and range. So let's do our domain and range. You have to have done it in proper set builder notation. You won't get the mark if it's not in proper set builder notation. So x is such that, tell me what x cannot be. So it can't be 4, and it can't be negative 3. But other than that, x belongs to the element of the real numbers. Range. Tell me what y could not be. The HA you have to list, and the y value on the whole. So 0 and negative 1 over 7. Okay, so we've got our domain and range. Now we just need our x and y intercepts. So what you could do, you could put it into the original or into the factored form. So let's get actually, it's easier to deal with the factored form of this equation. So let's write the factored form, which was y is equal to 1 over x minus 4. Okay, if you were looking for the y-intercept, you're going to let x equal 0. And you'd have y is equal to 1 over, if this guy is 0, it'd be 1 over negative 4. That's your y-intercept. When x is 0, we'll have negative 1 over 4. You would see, you'd get the exact same thing if you plug that into the original as well. Okay, you'd have, it would reduce to 1 over negative 4. To get the x-intercept, we're going to let y equal 0. Okay, and watch what happens here. If this becomes 0, then you say, okay, you want to get rid of this denominator, so multiply both sides by x minus 4. Something's going to happen. X minus 4, x minus 4. This will cancel and give me a 1. You know what would happen over here? If I've got 0 times x minus 4, what would be on the left-hand side? 0. This is not true. So what that means is there's no x-intercept. Okay. What I'm going to do is I'm going to hand out your review packages, and I'm going to tell you which ones specifically in rational functions with the graphs, which ones I want you to work on.